Hey gang, welcome to Mr. Gash's pre-calc e-learning style. We're going to cover chapter 13.2, Permutations and Combinations. We're just going to review a little bit from the previous section where we left off with chapter 13.1, which is the counting principle. So let's try this out here. There we go. Hold on to your cookies. So the big idea of this one here is the numbers in A. Like my little drawing here. The numbers in A. There we go. The numbers in A. The whole circle. If I add those up, and then I add up the numbers in B, okay, that gives me the union. Okay, that gives me the numbers in A union B. Well, the problem with me adding up all in A and then all in B here is that we're adding this overlap, the intersection, the dark part. We're adding that twice. So what this formula tells you to do is take all the numbers in A, take all the numbers in B, and then subtract the overlap. That's all that's going on. Okay, so there's my little Venn diagram for you guys. Okay, very high tech. So as I take a look, they're going to give you some problems here on the notes. They tell you the numbers in A is 20, the numbers in B is 40. Well, if I add all those up, 20 plus 40, well, that's 60. Well, I just added the intersection twice. So there's the problem. So we set those and we plug those into our formula. Okay. So the union is 50. Our numbers in A are 20. The numbers in B are 40. And then I subtract the intersection. Well, 20 plus 40 is 60. Subtract the 60 over and I get negative 10 equals a negative numbers in the intersection, and then divide and we end up with 10. Okay. So in the next one, this time they give us the union, the overall of A and B added together is 60. The intersection is 40. They want us to know what the numbers in A are. Well, they also tell us that A and B are the same. So we take our formula and we plug in those numbers. We know the union is 60. We know the numbers in A and B are the same, so we just have those the same. If you want to mark them as X, you can. And then the numbers in the intersection is 40. So we go ahead and add that 40 over. That's a hundo. Is 2 times X or 2 times the number in A. We divide and we should get A is 50. Okay, so that's just a little review of the last part that we talked about before you left. And now we're looking at moving on to our goals for today. Again, we're looking at the counting problems of multiplication principle, permutations, and combinations. You're going to need your calculator for this, so I recommend grabbing that thing. Hopefully you got that available. And I'll show you how to do some of this by hand, and then afterwards you can just use your calculator. So here we go. So multiplication principle basically says if I have a bunch of choices, so I have P choices or selections for the first choice, I have Q possibilities for the second choice, and I have R selections for the third choice. To find out all the different possibilities there are, all I do is I take P times Q times R. Okay, so for example, back in the day, they used to have TGI Fridays, if you remember TGI Fridays. Now it's Texas Roadhouse. Anyways, TGI Fridays was big on having this big dinner where you get a choice of an appetizer, an entree, and a dessert for a fixed price, let's say $19.99. And then they said over 50 choices to choose from. Well, what they're doing is the multiplication principle. So for example, this TGI Fridays, they have soup and salad, so there's 2 choices there. Okay. The entree, we have baked chicken, broiled beef patty, beef baby liver, or roasted frog legs. Okay, that's another choice. Looks like 4 choices there. And then the dessert. Okay, we have ice cream or cheesecake. So wash those frog legs down with the cheesecake. I take the 2 options of appetizer. I take the 4 of the dessert, and then I take the 2 of the 4 of the entree, 2 of the dessert, and multiply them all together, and you get that 16 meals. Okay, so all we're doing is we're taking all the possibilities and multiplying them together. So The next question you see on your notes is involving license plates. Okay, so this is a cosine of 0 equals 1, which we'll hit up in chapter 6. Okay, you guys are looking forward to trig, getting triggy with it. Jedi, I am, yeah. Yoda. I don't have a Yoda around me anywhere. But anyway. License plate consists of a letter and then 5 numbers. How many different types of license plates are possible? And if it doesn't say, it's assuming that we know that we can repeat numbers, okay, and letters. So I take a look. Here's my license plate. Okay, we have letters right here. Now, if you don't know how many letters in the alphabet, well, you might have to ask mom and dad, but hopefully they told you there's 26 letters. Okay, so A through Z, there's 26. Okay, and then 5 numbers. How many single-digit numbers are there? And I hear people say 9, and it's not 9 because you forget about 0. So it's 1 through 9, and then you also have 0, so you have 10 choices. Well, again, you can repeat for the next digit. So it's 10, and then 10, and then 10, and then 10. And we multiply those together. It's 26 times 10 to the 5th, which is 2,600,000 different license plates with that scenario, having a letter and 5 numbers. Take a look. Hang on. Here we go. Okay, so the next one is we have airports. Okay, so it says the International Airline Transportation Association, also known as the IATA, assigns 3-letter codes to present or represent airport locations. Chicago O'Hare is given the ORD code. Okay, so we have a 3-letter code, and Chicago O'Hare's ORD. Does anybody know why it's called ORD? Anyone? Anyone? Bueller? Yes, you're right. It's because Chicago O'Hare used to be an apple orchard. ORD is for orchard, believe it or not. So repetition, I just made that up. I'm just kidding. No, Google it. It's true. I did not make that up. Anyway. All right, so repetition is allowed for forming our codes. How many airport codes are there possible? So again, we have a 3-letter code. So we have 3 blanks. I always put the blanks down. It just makes me understand what's going on. And then I say, well, how many choices do I have for the first letter? Well, there's 26. I can repeat. So the next one's 26 and 26. Okay, or 26 to the 3rd power, which is 17,576 airports. So kind of cool. So we take a look at the next one. So factorial symbol, you guys should be able to know where the factorial symbol is. Some rules there. Factorial just means just multiplying until you end at 1. So if I have 3 factorial, that's 3 times 2 times 1. If I have 4 factorial, that's 4 times 3 times 2 times 1. Okay, that can get awfully tedious. Okay, so as I take a look in the math menu, so if you guys take your fancy calculators on, if you can get that thing going on. Okay, we go to the math menu here. Yeah. Yeah, you see that? All right, so we toggle on over and you see PROB. So toggle on over PROB, and you should see the factorial symbol there. It's right there, number 4. So math menu, PROB, all the way down to number 4. Also take a look at number 2 and 3. That is a NPR and an NCR there for number 3. We'll walk you through how to do permutations and combinations with the calculator. Okay, so factorial symbol, if I want to do 7 factorial, yeah, I could do 7 times 6 times 5 times 4 times 3 times 2 times 1. Or type in 7 and then go to the math menu, over to PROB, down to number 4. Okay, I could just do that. 7 factorial, press enter. And I got 5,440. So 5,040. And again, you can do it by hand or you can use your calculator. So 10 factorial, that's 10 times 9 times 8 times dot, 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 dot. Or you can just do 10 exclamation point, which is the factorial symbol. So math menu over to PROB, down to number 4, the exclamation point, and I got 3,628,800. Okay. All right. So math menu, toggle on over to PROB, and then the exclamation point. So as I take a look, permutations with repetition, without repetition here. Again, this is essentially the multiplication principle, except you can't repeat things. Okay, so there's formulas for this. They just tell you that n is the number of objects that you have, and they're distinct, so you can tell one from the other. Once an object is used, you cannot repeat it. So anytime it doesn't say that you can repeat. So if it says you cannot repeat, we're looking at a permutation. If you can repeat, that is a multiplication principle. So I repeat. If you can repeat, it's a multiplication principle. Okay? So order is important for permutation, so it matters who's first versus who's second, who's third, okay, in order. So I take a look, find the value of a permutation. I have 7 things and I have 2 spots to fill. Okay, so I could use the factorial of n factorial divided by n minus 2 factorial, so I could do that by hand. 7 factorial is 7 times 6 times 4 times 3 times 2 times 1. And then 7 minus 2 factorial is 5 times 4 times 3 times 2 times 1. Well, what happens with this, if you're doing this by hand, the 5s, the 4s, the 3s, the 2s, the 1s all cancel, and what you're left with is 7 times 6. Basically, I have 2 spots. I have 7 options for the first and 6 for the second. Okay, and that's 42. All right, well, if I have a fancy calculator here, like this guy, first thing I do is I go back to that math menu. I go over to PROB, and I go down to number 2. If you look at number 2, I got NPR. Okay, so number 2, NPR, math menu, probability, NPR, and then I type in the numbers. So the big number always comes first. So I have 7 choices, 2 at a time, and it's going to look like this. So anytime I want to do permutation, just like that. Okay. Now, if you have a TI-83, you have to press 7 first, then go to the math menu to PROB to number 2. Press that, and then press 2, and then press enter, and you should get the number 42. So again, if you have TI-83, do number 7 first, press number 7, then go to your permutation, then 2, and then enter, and it should work out and give you 42. Okay. From here on out, I don't care how you do it. Do it by hand, do it with your calculator. It doesn't matter. Calculator is your friend, so let's use our friend. Okay, right now it's the only friend we got, right? Social distancing. Here we go. All right, so permutation, 4 things 4 at a time. Now you could use your calculator, or just do 4 times 3 times 2 times 1. I have 4 choices. I can't repeat, so I have 4 for the first, 3 for the second, 2, and then 1, and then I get 24. You can plug that in your calculator as well. That'd be 4 NPR 4, and then you should get 24. All right. So, question is, how many ways can 5 people be lined up? So, question is this a permutation or multiplication principle? Well, once you use somebody, you can't use them again, right? There's no clone here. This isn't Star Wars or something, okay? So, we got a boy band, right? I got Jimmy here in the middle. I got Johnny here on the left, and I got Mickey on the right, and then I got Joe and Mike there, whoever these guys are, I don't know. And then the album guy's like, hey, let's rearrange them. So let's put Mikey on the left and Jimmy on the right, and they move them all around, and it makes it look very different, right? And then they line them up a different way, and this One Republic band, there's 5 guys and there's 5 spots, and once you use one of the guys, you can't use them again. So that's a permutation. Order matters. It looks different to have the guy with the fuzzy hair here on the left than it does on the right. It just is a different order. So order matters. So permutation, 5 things 5 at a time, or you could think of it as the multiplication principle without repeating. Again, there's 5 choices, then he's used, so then there's 4, then 3, then 2, then 1, and then I press enter, and I get 120 different ways to do that scenario. Okay, so again, the permutation and the multiplication principle are the same, except permutation you can't repeat. All right, so moving along here. So I take a look. It says how many different three-letter codes are there if only letters A, B, C, D, and E can be used. No letter can be used more than once. So number one, you got to count. Okay, we got a three-letter code, and we got to count letters. So, okay, A, B, C, D, and E. So that's 5, right? So the big number comes first. Okay, you can't use a letter again. So again, you can't repeat. So this is a permutation. This is a permutation. Oh, doctor. What happened? All right, let's pause you. All right, we're here. All right, so sorry about that. That's permutation of 5 things, 3 at a time. So we have A through E to choose, and then we use one of them, and then it's 4 and then 3. And again, you can use your calculator, 5 times 4 times 3, or just do permutation 5 things, 3 at a time, press enter, and you should get your 60 codes. Okay. I wish I could take questions right now, but this is welcome to learning. All right, last but not least, we have combinations. Okay, so combinations is exactly like permutations. End is a distinct object. Once an object is used, it cannot be repeated. Okay, exactly the same. But the last thing is the most important thing. Order is not important. Okay, you're just looking at taking a group of people and putting them together. Okay, so gym basketball. Okay, there is no positions in gym basketball, right? 5 guys on the team. It doesn't matter who's picked first or last. If you're not first, you're last. Okay, so it doesn't matter. You're still on that team. Okay, so again, combination. If you look at your formula here, okay, it's exactly the same if you cover up this R factorial here. Okay, but because we're dividing by a bigger number, combinations are usually smaller. Okay, so A and B is the same thing as BA. Okay, where in permutations, AB is different than BA. Okay, so we would count that. Where in this case, AB and BA are the same thing, so we don't count. Okay, so order does not matter. I have 8 things, and I have 2 spots to fill. Okay, so I have my calculator here. Okay, we can turn this guy on here. We can go to the Math menu, over to PROB. Okay, and then we got number 3. So toggle down to number 3. So I got 8, 2 spots. I press enter. Look at this. Boom, 28. Okay. Now you can use your calculator. You can do it by hand. If you want to do it by hand, it would be 8 factorial divided by 2 factorial times 8 minus 2 factorial. Okay. And that's 8 times 7 times 6 times da 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 da. The 6 factorials are going to cancel. And you get 8 times 7 is 56 divided by 2 is 28. Okay. Exact same thing we got in our calculator. If you're using the TI-83, type in 8 first, then go to the Math menu, PROB, do number 3. That's a combination. Okay. So you can throw this in your calculator, double check to make sure you're getting it right. You should get a combination of 7 things, 4 spots, 35. Okay. All right. So examples you'd see in real life involving a committee. Okay. This is a famous movie. You've seen this before. Yeah. 12 Angry Men. Yeah. Again, think of a jury. It doesn't matter when you're selected. You're in a group of people. Everybody has the same hierarchy. Everybody is, on the round table here. It doesn't matter who's King Arthur here, right? So this little guy here says how many different committees of 3 people can be formed from a pool of 7. Okay, so when you see committee starts with the letter C. Okay, or like this. Okay, so it starts with a C. That's a combination. Combinations are committees of people, groups of people. Okay, where there's no hierarchy. There's no president. There's no vice president. Okay, no secretary of state. It's all everybody on the same level. So that's a combination. so again, a combination of 7 things, 3 at a time. Plug that in our calculator and we get 35 possible committees that we can create. Alright, so last but not least, number 13, and I know you guys want to be done here, so let's get moving. It says, in how many different ways can a committee consisting of 2 faculty members and 3 students be formed if 6 faculty members and 10 students are eligible to serve? So you got the idea of a combination here, but you also have the idea that I've got faculty members and I got students. Okay, so I have choices here. All right, so number 1, we got to look at the committee of faculty members. There's 6 guys to choose from, and there's only, what, 2 spots. Okay, so that's a combination of 6 things, 2 at a time. And then we look at our students. Okay, so 6 things, 2 at a time. If I plug that in, that's 15. I look at my students. Okay, that's a combination of there's 10 students and 3 spots to fill. Okay, now what we have to do is decide. This is all the choices of committees for faculty members. This is all the choices of committees of students. Well, what do you do when you have choices? We multiply them together. Okay, don't add them. Okay, this is the multiplication principle, not the addition principle. All right, so multiply your choices together. This is my choices for appetizers and entrees. Okay, we multiply those together and I get 1,800 different possible committees. Okay. All right, ladies and gentlemen, that is it. I am done with permutations and combinations. If you guys have questions, please feel free to email me. I'm going to try to figure out a good way for us to answer questions, whether it's just a video of some sort or what have you. And I'll be here for you. See you guys. Stay healthy.